In this module, you will learn about trigonometric functions. Take a look at the right-angled triangle ABC, right-angled at B. We know that in this triangle, the ratio of any two sides in a particular order gives rise to 6 different trigonometric ratios for the angle theta. That is, AB divided by AC is sine theta. BC divided by AC is cos theta. AB divided by BC is tan theta, and so on. Let's now extend the definition of trigonometric ratios to any angle in terms of its radian measure and study them as trigonometric functions. Consider a unit circle such that its center is at the origin. This circle intersects the x-axis at points A and C with the coordinates 1, 0 and -1, 0 respectively, and intersects the y-axis at points B and D with the coordinates 0, 1 and 0, -1 respectively. Let P be any point on the circle with the coordinates A, B in the first quadrant, such that angle AOP is equal to theta radians. We know that in a circle of radius r, if an arc of length L subtends an angle theta radians at the center, then L is equal to r theta. Using the formula, we get that length of arc AP is equal to theta. Drop a perpendicular from point P such that it intersects the x-axis at M. Point M is at a distance of A units from the origin on the x-axis and length MP is B units. Also, OP being the radius of the unit circle is equal to 1. Thus, we obtain a right-angled triangle OMP. By Pythagoras' theorem, the sum of the squares of the perpendicular and the base is equal to the square of the hypotenuse. Thus, A square plus B square is equal to 1. Now, corresponding to the angle theta radians, we define the trigonometric function cosine as cos theta is equal to A, and the trigonometric function sine as sine theta is equal to B. In equation 1, substituting the values of A and B, we get cos square theta plus sine square theta is equal to 1. This shows a relation between the sine and the cosine functions for any real theta, which is a very important result in trigonometry. Angles that are integral multiples of pi by 2 are called quadrantal angles. Let us find the values of sine theta and cos theta when theta is a quadrantal angle. When theta is equal to 0 degrees, point P coincides with point A. It implies that sine 0 degrees is equal to 0 and cos 0 degrees is equal to 1. When theta is equal to pi by 2, then point P coincides with point B. It implies that sin pi by 2 is equal to 1 and cos pi by 2 is equal to 0. When theta is equal to pi, point P coincides with point C. It implies that sin pi is equal to 0 and cos pi is equal to -1. And when theta is equal to 3 pi by 2, point P coincides with point D. it implies sin 3 pi by 2 is equal to minus 1 and cos 3 pi by 2 is equal to 0. This way, if we take one complete revolution from point P, we come back to the same point, P, again. It means that if we increase or decrease the value of theta by an integral multiple of 2 pi, the values of sin theta and cos theta do not change. Hence, sin 2n pi plus theta is equal to sin theta, where n is any integer. Also, as we saw, since sin 0 degrees and sin pi are 0, sin theta is equal to 0 when theta is an integral multiple of pi. That is, at 0, plus or minus pi plus or minus 2 pi, and so on. Similarly, on increasing or decreasing the value of theta by an integral multiple of 2 pi, the value of cos theta also does not change. Therefore, cos 2n pi plus theta is equal to cos theta, where n is any integer. We just saw that the values of cos pi by 2 and cos 3 pi by 2 is equal to 0. Similarly, cos theta is equal to 0 when theta is an integral multiple of pi by 2. That is, at plus or minus pi by 2, plus or minus 3 pi by 2, and so on. Thus we can say that if sin theta is equal to 0, then theta is equal to n pi. And when cos theta is equal to 0, then theta is equal to 2n plus 1 into pi by 2, where n is any integer. Let us now define the other four trigonometric functions, tangent, cotangent, secant, and cosecant, in terms of sine and cos. Tan theta is equal to sin theta divided by cos theta. Tan theta is defined when the denominator is non-zero. Now, cos theta is 0 when theta is equal to 2n plus 1 into pi by 2. Therefore, tan theta is defined for theta not equal to 2n plus 1 into pi by 2, where n is any integer. Cot theta is equal to cos theta divided by sin theta. It is defined when the denominator is non-zero. We know that sin theta is 0 when theta is equal to n pi. Therefore, cot theta is defined for theta not equal to n pi, where n is any integer. Secant theta is equal to 1 divided by cos theta. This function is defined when theta is not equal to 2n plus 1 into pi by 2, where n is any integer. Cosecant theta is equal to 1 divided by sin theta, which is defined when theta is not equal to n pi, where n is any integer. Using the above four trigonometric functions and the result sin square theta plus cos square theta is equal to 1, we can arrive at two more results that you have already studied in earlier classes. 1 plus tan square theta is equal to sec square theta, and 1 plus cot square theta is equal to cosec square theta. The table here shows the values of trigonometric functions for some standard angles. Let us now see the signs of trigonometric functions in different quadrants. Consider a unit circle such that its center is at the origin. This circle intersects the x-axis at points A and C, and the y-axis at points B and D as shown. Let P be any point on the circle with the coordinates A, B in the first quadrant, such that angle AOP is equal to theta radians. Let us now suppose a point Q in the fourth quadrant such that the measure of angle AOQ is also theta radians. However, this angle is negative as it is in the clockwise direction. It implies that the coordinates of point Q are A, minus B, since the y-coordinate in the fourth quadrant is negative. Now, corresponding to the angle theta radians, we define the trigonometric function cosine as cos theta is equal to A, and the trigonometric function sine as sine theta is equal to B. Let us find sine of minus theta. This is equal to minus B, since the y-coordinate of point Q represents sine of minus theta. This is equal to minus sine theta. Similarly, cos of minus theta is equal to A, since x-coordinate of point Q represents cos of minus theta, and this is equal to cos theta. Now, tan of minus theta is equal to sine of minus theta divided by cos of minus theta, and sine of minus theta is equal to minus sine theta, and cos of minus theta is equal to cos theta. Therefore, tan of minus theta is equal to minus tan theta. Similarly, cot of minus theta is equal to minus cot theta. Secant of minus theta is equal to secant theta. Cosecant of minus theta is equal to minus cosecant theta. Now, take any arbitrary point P with the coordinates A, B, which lies on the unit circle. The values of A and B lie between -1 and 1. In other words, the values of cos theta and sin theta lie between -1 and 1. Let us now see the signs of trigonometric functions in different quadrants. In the first and the second quadrants, y-coordinate is positive, which implies that the sine function is positive in the first two quadrants. In the third and the fourth quadrants, the y-coordinate is negative, and hence the sine function is negative. Similarly, x-coordinate of point P is negative in the second and the third quadrants, and therefore the cos function is negative in these quadrants. Similarly, x-coordinate is positive in the first and the fourth quadrants, and therefore the cos function is positive in these quadrants. Similarly, we can find the signs of the other 4 functions in different quadrants. From the above table, we can say that the sign of a trigonometric function depends upon the quadrant in which a point lies. On summarizing the table, we can say that in quadrant 1, all the trigonometric functions are positive. In quadrant 2, the sine and cosecant functions are positive. In quadrant 3, the tan and cot functions are positive. In quadrant 4, the cos and secant functions are positive. If we denote A for all, S for sine, T for tan, and C for cos, then the figure can be represented as shown. A trick to remember this would be to remember the phrase, all silver teacups, or a smart trick class, or add sugar to coffee, starting in the first quadrant.